Hello class, in this lesson I'm going to show you the topic of squaring a binomial. In learning to square a binomial, there are actually two different types of binomial squaring. One is called the perfect square trinomial, and then the other one is called the difference of two squares. So before we begin, let's go ahead and define some of these words because I know that I threw a bunch of terminologies at you. If you recall, binomial is actually two monomials put together. So it would look like this. So this example, x plus 2, is a type of binomial. So when we talk about squaring a binomial, we're going to take this quantity, x plus 2, and square it. So it would look like this. So the quantity x plus 2 raised to the second power. That is squaring a binomial. So if we were to work this out, this quantity x plus 2 squared is the same thing as saying the quantity x plus 2 times the quantity x plus 2. And if we were to use the FOIL method in multiplying this out, we would get x squared plus 2x plus 2x plus 4. Adding the like terms of 2x and 2x, the final answer would be x squared plus 4x plus 4. Okay, so let's do another example, and hopefully once we go through a couple more examples, you'll start to see the patterns. So let's say we have x plus 3 squared, which we know is x plus 3 times x plus 3. Using the FOIL method again, we would get x squared plus 3x plus 3x plus 9. Adding the like terms together, we would get x squared plus 6x plus 9. Okay, and then adding one more example, x plus 4 squared, that gives us x plus 4 times the quantity x plus 4. Using the FOIL method again, we would get x squared plus 4x plus 4x plus 16 equals x squared plus 8x plus 16. So let's take a look at these results. We started out with x plus 2 squared, and we ended up with x squared plus 4x plus 4. Do you notice any patterns here? X plus 2 quantity squared, x squared plus 4x plus 4. Okay, let's take a look at the next one. We started out with x plus 3 quantity squared, and we landed with x squared plus 6x plus 9. Okay, take a couple seconds and just look at both of those examples. What do you notice here? X plus 3, x squared plus 6x plus 9. And then let's take a look at the last example. X plus 4 quantity squared. The result is x squared plus 8x plus 16. Do you see any trend or pattern going from here, the first example, to the second example, to the third example? So in each of these terms, okay, whenever you have an x plus something, the first term is always x squared, right? X squared, x squared, x squared. Okay? And then we're going to go to the last term. Look at this. We have a 4. This 4 is this number squared, correct? This is, so 2 squared is 4. Look at this next one. This number 3 squared is 9. This number 4 squared is 16. Okay, so we've got the first and third terms figured out. First term is always x squared. The last term is the second term squared. What about the middle terms? What do we see here? Okay, what we do notice is that they all have x's, so we know that this x is involved somehow. Okay, but what is the relationship between this x and 2 versus this 4x? Or this x and 3 versus this 6x? Or this x and 4 versus this 8x? If you'll notice, the pattern is if you take the product of these two numbers, so instead of saying x plus 2, we say 2x, and then double it. Now it becomes 4x. And that's the second term. Let's see if this works with the second example. Multiply these together, we get 3x. If we double it, we now get 6x. Okay, how about this last one? Multiply these together, so it becomes 4x, and if we double it, this becomes 8x. Interesting, isn't it? So given these three examples, maybe we can come up with a formula. A formula that will help us to solve squaring of binomials in a much simpler way so that we don't have to go through the FOIL method every time. We can simply go from here to the answer. So let's try to derive an equation. Let's suppose we have a plus b quantity squared. What would that equal to? Well, we did say that the answer of the first term will be this first term squared, right? So therefore, we know it's going to be a squared. Okay? Now let's go to the last term for a second. We know that these last terms, 4, 9, and 16, are the squares of the second term. 2 squared is 4, 3 squared is 9, 4 squared is 16. So we know it's going to be plus b squared. Okay? So now we just have to figure out the middle term. And we said earlier that if we multiply a and b together and double it, then we have the middle term, right? So this 2 times x, that's a and b, and if we double that, we get 4x. Same thing with 3 and x. If we multiply together and double that, we get 6x. Therefore, the middle term would be 2ab. This equation that we just derived will help you to square a binomial. Okay? And what results is a perfect square trinomial. This is the perfect square. Okay? And because we have 3 terms here, this is called a trinomial. And there we have it, perfect square trinomial. So let's take a look at a different scenario. What happens if we have x minus 2 squared this time? Instead of x plus 2, we now have x minus 2. So doing the same thing again, we know that x minus 2 quantity squared is the same thing as x minus 2 times x minus 2. If we were to FOIL this, it becomes x squared minus 2x plus 4. And that simplifies to x squared minus 4x plus 4. Let's do another example. X minus 3 squared. That becomes x minus 3 times x minus 3. That is equal to x squared minus 3x plus 9. And that simplifies to x squared minus 6x plus 9. And let's do one more. X minus 4 quantity squared is equal to the x minus 4, the quantity x minus 4 times the quantity x minus 4. Using the FOIL method, that comes out to x squared minus 4x plus 16, and that simplifies to x squared minus 8x plus 16. Okay, so let's take a look at what's going on here. We started out with x minus 2, x minus 3, x minus 4. Look at the patterns of the first term. It's x squared, x squared, x squared. So we know that the first term is going to be the square of this first term. Okay, now let's take a look at the last term. It's the same thing as we had before. If we take the second term here and square it, okay, negative 2 squared becomes 4, negative 3 squared becomes 9, negative 4 squared becomes 16. Okay, and then look at the middle term. If we take the first term and multiply it by the second term, that becomes negative 2x. Okay, and if we double that, we get negative 4x. Same thing here. Multiply these together, we get negative 3x. Double that, and we get negative 6x. Similarly, multiply these together, negative 4x, double it, and we get negative 8x. So I think we can derive another equation. So if we have a minus b quantity squared, we know that this becomes a squared. Okay, the first term is squared, as we said over here in all three of these scenarios. And we also know that it ends in the last term, or the second term, squared. Negative 4 squared is 16, negative 3 squared is 9, negative 2 squared is 4. So we know that this is going to be positive b squared. Oops, b squared. Okay, and we just noticed that the middle term is the product of the two, right? We multiply these two together, that means the product of the two, and then we double it. So the answer will be minus 2ab. And this is also a perfect square trinomial. Okay, so let's summarize what we have so far. We know that if we have the quantity a plus b squared, that is equal to a squared plus 2ab plus b squared. Similarly, if we have the quantity a minus b squared, we know that that's going to result in a squared minus 2ab plus b squared. Okay, so here are the two formulas. You don't have to remember this. You can always still use the FOIL method, but if you do memorize this pattern, it'll help with your calculations, and it'll help you to multiply polynomials much faster. Okay, so let's take a look at a couple of examples here. Let's say we have x plus 4. No, we've already done that. Let's say x plus 8, quantity squared. Okay, if we use the formula that we just derived, we know the answer is x squared plus double the product of the two terms, so that'll be 16x plus 64. Okay, let's try another example. Let's say we have 2y squared plus 5, quantity squared. Well, if we follow this first equation, okay, it just becomes 4y to the 4th. Okay, we are taking this and multiplying it by itself, so that's why we have 4. This becomes 4, and then y squared doubled becomes y fourth, y to the 4th, okay, plus the product of these, which would be 10y squared doubled, that becomes 20y squared, plus the second term squared, and we get 25. And if we do another example where we have c minus 7 quantity squared, by following this formula we get this result, which becomes c squared minus the product of c and negative 7 doubled becomes negative 14c plus 49. Second term squared. Negative 7 squared is 49. Okay? So these are perfect square trinomials. All right, one more example. What happens when we have difference of two squares? Well, what do I mean by that? Let's take a look. Let's say we have x plus 2 times x minus 2. When we have this scenario, x plus 2 and an x minus 2, this is called a conjugate pair. Conjugate pair. It's a conjugate pair because the first term and the second term are the same in both scenarios. The only difference is the signs are different. We have a positive here and a negative here. So if we were to work this out and use the FOIL method, we'd find that this is equal to x squared plus 2x minus 2x minus 4. And if we simplified that, we get x squared minus 4. Okay? Hopefully you're starting to see a pattern, but let's just do one more. X plus 3 times x minus 3. That is equal to x squared plus 3x minus 3x minus 9. And that simplifies to x squared minus 9. Do you see a pattern here? If you take a look at both of these examples, you notice that the middle terms cancel each other out, and we're left with the first and the fourth. Okay? So if we were to derive a formula where we have a plus b times a minus b, that's going to equal the first term squared minus the product of the last two terms. So in other words, we're going to multiply b times negative b, and we get minus b squared. The result here is called the difference of two squares. Okay? This is a square, this is a square. It is the difference, right? This is what that negative is, difference of two squares. What this means is, whenever you have something like this, let's say it's r plus 3 times r minus 3, we don't have to go through the FOIL method. We can take r times r, which is r squared, and we take positive 3 times negative 3, gives us a negative 9, minus 9. Okay, so then through this exercise, we've derived three different formulas. They are a plus b quantity squared, a minus b quantity squared, and then we have a conjugate pair, a plus b times a minus b. All of these equal to a squared plus 2ab plus b squared. The second one is a squared minus 2ab plus b squared. And then the last one is a squared minus b squared. Okay, hopefully this made sense to you. Again, you don't have to memorize this formula. but if you do, it'll make things easier when you encounter these scenarios. Worst case, you can always use the FOIL method to multiply these polynomials. If any of this didn't make any sense, please go back to the beginning of the recording and play it again. Thank you.